Hello all, welcome to Engineering Economy course. We are continuing our discussion on time value of money and we are learning how to find equivalence calculations. We learned how to find present, future, annual words of different types of cash flows, and in our previous lecture we learned about the linear gradient payment series, and in today's lecture we will learn another payment series which is called geometric gradient payment series. So let's get started. In our previous lecture we learned that sometimes the payments or earnings may increase or decrease as a linear range from one period to another. So if you, for example, earn $100 in at the end of the first period, then, for example, each period your earnings or payments may increase with a certain amount, say $20. So at the end of the second period you earn 120, and at the end of the third period you earn 140, and etc. In this case, the payment series is linear. The increase in the payment is linear. So this is year one and you earn $100. Then you earn 120, you earn 120 in at the end of year 2 and 140, and it goes in this way. So this is a linear increase, as you can see, and the difference between two consecutive earnings is 20. Okay, and we learned how to find the present word, future word for these type of payment series. There is another common payment series in which the earnings or payments do not increase at a constant rate, at a constant value like $20 in my previous example, but it increases at a constant percentage. So this percentage can be represented by G, or sometimes we will refer it by F. Don't be confused. These two things are exactly the same. So what happens, for example, at the end of the first year, you make a payment of A1, let's say $100. And then at the end of the second period, you increase this by a constant percentage, let's say 10%. We increase our earnings or payments. So 10% more means we multiply this by 100 by 1 plus 0.1, and our earnings becomes 110. Okay, so at the end of the second period, if the first payment is A1, if the first earning is P1, the second earning becomes A1 times 1 plus G. And then at the end of the next year, we increase this amount, 110, again by 10%, and this time we earn this much. Okay, it is equivalent to A1 times 1 plus G, the rate of increase, the percentage of increase squared. And it goes in this way. The last payment would be the number of periods minus 1 to the power. Okay, if this is the case, we call this a geometric gradient series. Our payments or earnings are increasing geometrically, and the thing is, this shape over here represents an increase of, let's say, 10% in our earnings. But we may even reduce our earnings so that in the first period, for example, let's say we earn $1,000. In the next period, instead of increasing this by 10%, we reduce it by 10%. And this time, actually, we multiply this 1,000 by, again, we call it 1 plus G, but this time this G, since it's a reduction, it is minus 10%. Okay? So it means that 1 minus 0.1, 1,000 times, so we earn $900, okay, in the second period. And in the third period, we even multiply this one more time with 1 minus g, so it makes 1 plus g square. So this plus, okay, is used to have the same, exactly the same formula for increase and decrease. But what is changed between these two cases is, in the first one, g is positive, okay? But in the second one, this g is negative. And when g is negative, actually, our earnings or payments are not increasing, but this time they are decreasing geometrically. And if we have such a payment series, okay, then we can calculate the present worth of these payment series using formula. And actually, this formula consists of two parts. The first part represents the case when the interest rate is different than the increase or decrease rate of earnings. Okay? Why we divide this into two? Because of this. Look at this formula. In the formula, we have I minus g at the denominator. And if I is equal to g, it will make a1 divided by 0. And mathematically, this is undefined. Therefore, we find this case in a different way, as shown here at the second part of the formula. So if the interest rate is exactly equal to the increase rate of the payment series, then we use this formula. Otherwise, we use this formula. And again, if the payments or earnings are increasing at this rate, then this g is positive. It's greater than 0. Otherwise, we write it as negative, less than 0. And this I is the interest rate, A1 is the first payment, N is the number of periods. Okay, so we can represent this with factor notation using this. P given A1, G is the increase rate in the cash flows, I is the interest rate, and N is the number of periods. But the thing is, if you look at the back of your book to the factor tables, you will not see these factors in those tables. Okay, so these factors does not appear in the factor tables. We just use this for notational simplicity. In order to calculate this value, we need to use this formula over here. Of course, when you calculate the present value, the calculation of the future value is equivalent. You just use the formula P times F given P, interest rate, and N factor to calculate the future. And similarly, you can calculate the annual equivalent payment series by A given P, I, and N. Okay, so once you get the present worth, you can calculate the future or annual worths from these other formulas. So the formulas are summarized in these equations once again, but as I told you, F and G, we can sometimes use G or we can sometimes use F to represent the rate of increase in the payments. So don't be confused because of that. And also, if you compare this equation with the previous one, you will see that actually they are not identical. They seem to be different because actually we do some mathematical operations to convert that equation to this one. Both equations are exactly the same. Okay, they are not different. We convert it to this version for a purpose you will understand in a few minutes. Okay, again, when the rate of increase is not equal to I, we use this formula. Otherwise, if it's equal, if they are equal, we use this formula. Now let's pay attention to this formula. Let's look at this part over here. 1 plus I to the power minus n. So this part actually is similar to finding the present worth for which a future worth is given. Okay, so this is finding P given F for interest rate of I. But look at this second part over here. Again, this F is a rate, is a percentage like this I. So this second one, if you see this to the power is positive now, it is like F given P this time. We are finding a future value given a present word, but this time instead of the interest rate, we are using the growth rate, the increase rate of the cash flows. So F. Okay, so now we can represent the first part of the formula as, look, this part is P given F, interest rate is I%, and number of periods is N. And the second part here is F given P, but instead of the interest rate, now we are using the increase rate of the cash flows and the number of periods. And have a look at this part over here. It is also the second part of the calculation of the equation. It is again P given F, and as you can see, the interest rate is used. Therefore, we can represent it with this factor formula. Okay, so these two are exactly the same thing. In the first one, we are using the formulas, but in the second one, we make use of the factors. And you can just go and look at these values in the factor tables to calculate the present word. And as I told you, when you calculate the present word, you can easily and quickly calculate the future word or the annual word. So look at this. Sometimes in some questions, we do not just tell you, or the question just don't tell you that the cash flow is increased by 20% and etc. But they just give the cash flows like this. At the end of first year, you have 1,000. You have an earning of this much. At the end of the second year, the earning value. At the end of the third and fourth years. Now, when you look at these values, you would see that they are arbitrary values. You can assume that they are some arbitrary values. But if you just take the ratio of these payments, okay, so 1,200 divided by 1,000. Similarly here, 1,440 divided by this. And for the next one, 1,728 to 1440. Okay, you can see that the ratio of all these ratios are constant. And all these values, all these ratios make 1.2. Okay, what is 1.2? 1 plus 0.2. Okay, so from here you can understand that the rate of increase in the cash flow is 20%. Okay, so this actually represents a geometric gradient series where the rate of increase is 20%. 1,000, 1,000 times 1.2 to the power 1, to the power 2, and to the power 3. Okay, so whenever you have such a cash flow, don't just immediately assume that they are arbitrary, but just look at their ratios or the differences. If the differences of consecutive cash flows are the same, then it means that it is a linear gradient cash flow. But if the ratios are the same like this, 1.2, then it is a geometric cash flow series. So let's consider an example, and in this example it says that in this figure we have these end of year payments, which is a geometric sequence of cash flows. The rate of increase is 20%, this is F or G, and the interest rate is 25%. So it asks to find the present word, annual word, or future word. And future word. Okay, so you don't need to memorize the formula. The formula will be available for you. You just need to know how to use this formula, and believe me, if you don't solve questions by yourself, you will have difficulty in implementing these formulas because you will not know its specific instances or questions, you will not know which values or what values will you write for f or I or n. So the structure is very important. Look at this structure again. Like all other cash flows, like the uniform payment series or linear gradient payment series, the structure is very important. The first cash flow should appear at the end of year 1, and this is A1 amount. And the second cash flow should be 1 plus F times this A1. And all consecutive or all succeeding cash flows should be 10% or F% more or less from the previous one. And if we want to use this formula to calculate P, P will appear at time 0, 1 period before the time of first payment. This structure is very important because in this question it is very easy to figure out. Okay, so when you use this formula, you will obtain the present value here at time 0. But assume there is a question in which we have such a cash flow. Okay, let's say that this is time 1, 2, 3, and in time 4 we have a cash flow of, let's say, 100. Then in time 5 we have 120. Then it goes in this way, 144.4, 44, and etc. Okay, it goes in this way. So it means that there's a 20% increase in the cash flow, and we want to find this present value. Okay, so the geometric series increases in this way starting from the 4th period. Now, how can we find this present value at time 0? If you just use this formula over here, you will not find the present value at time 0. So it's important for you to know which present value you are finding using this formula. And the thing is, if you use that formula, you can calculate the present value 1 period before the first payment of the geometric series. It means that you will find this P. And then you need to shift this P to the present time, to time 0, using F given P formula or factor. Okay, so that's why the structure of the geometric payment series is important. You need to memorize that thing, but not the formula itself. Now let's find the present value using this formula over here. So since I is 25% and F is 20% and they are not equal to each other, we will use this first one. If they were equal, then we would use the second one. Okay, so then I can write this P is equal to A1. What is A1? A1 is the first payment, 1000. Then 1 minus, it says P given F, yes, okay, P given F. Interest rate 25%, okay, and number of periods in this example is 4. Then we have F given P. Now it says F%, and F is 20%. So simply write 20% and 4. Now you can assume that the tables at the back of the book is given for I. Okay, the formulas are for this, but here we have F. So can we use those tables at the end of the book? Yes, of course. Look, these are just numbers, 25%, 20%. It's not important whether we write here I or F. They are just notations. Their value is important for us. And their value here in this example is 20%, 25% and 20%. In order to find this value over here, just go to your book. At the end of your book, find the table with 20% interest rate. And for 20% interest rate, go to this number of periods 4, and F given P, number of period 4, please check it. You should find that it is 2.0736. And for this one, you need to go to the table with 25% and you should find P given F, and for 4, so please check it, it should be 0.4096. Okay, and divided by, according to this formula in the denominator, we have this, I minus F. Okay, so sometimes if you are not careful enough when we solve these questions, or if you don't solve these questions by yourself during the exam, what students do as a mistake is they just write here 25 minus 20. But of course you need to write their percentages here, and it means that I need to write here 0.25 minus 0.2. Okay? Otherwise it will be, you will obtain a wrong result. And this will give you the present word. Okay? So let's see the present word. When you use these factors and formulas, the present word, again look, I minus F is here, and the present word is equivalent to this much. Okay, you can ask this question. In this example, the interest rate was 25% and the rate of increase in the cash flows was 20%. So that I minus F value was equal to 0.25 minus 0.2, which is 0.05 that we used here. Okay. But if it was vice versa, if I was 0.2 and F was 0.25, then I minus F would be minus 0.05. It would be negative. So what shall we write into this formula? And you write exactly as it is, negative 0.05, right? Okay, don't be confused, just implement the formula. Okay, after obtaining the present word, so how can you find the future or annual equivalent? Simply for annual equivalent, we multiply the present word that we obtained by the factor A given P, 25% and 4, and you would obtain this result. And for future word, we simply multiply this by F given P formula, and we would obtain this future word. Okay? So there is no formula, or you don't need to know the formula for the annual equivalent or future equivalent. Of course, once you have this formula for present value, present word, you can multiply it, the formula, to calculate the future word, which is 1 plus I to the power n, and this will be the formula for future. But you don't need to know it. Okay? So first thing is to calculate the present word, and from that present word you can just calculate whatever you like, annual or future and etc. Now let's consider the same example, but this time let's assume that the cash flows do not increase, but this time let's assume that they are decreasing at a rate of 20%. So what would happen? Okay, so the cash flow for this case, of course, is not correct now, and we need to sketch the cash flow so that the first payment is $1,000, the second one is 1,000 times 1 minus 0.2, okay, and the third one will be 1,000 times 1 minus 0.2 to the power 2. So this time, this I is, the interest rate is 0.25, but F is minus 0.2. Okay, this negative is important. If you don't use it as negative, you will obtain a wrong result. So this would be 1, 2, 3, and for the fourth one, again, you will have 1,000 times 1 minus 0.2 to the power 3. Okay? So now we can use the same formula, exactly the same formula like this one, to find the present word. So it will be 1,000, the first payment, multiplied by 1 minus, okay, so it will be P given F, 25%, and 4. And the second one will be f given p minus 20% and 4. Okay, so pay attention, it is now minus 20%, it's important. And in the denominator, remember we write I minus f. So be careful with the sign, so it will be I 0.25 minus f. F is minus 0.2. Okay, so pay attention to this one. And the thing is, now how can you look at this factor over here? Because it is negative 20%, and at the back of your book there are no tables for negative values. So for this part over here, use the formula. Okay, remember this is f given p. It means that it is the fundamental theorem or fundamental formula of engineering economy. So we can write this 1000 divided by this part over here is 0.45 multiplied by 1 minus this p given f 25% and 4. You can look at the tables, factor tables, and you will find this value. And for the second one, we use the formula. It will be, remember, 1 plus I to the power n. This time, instead of this I over here, I need to write this negative value. So it will be 1 minus 0.2 to the power 4. Okay, so this would be the formula. And when you do this, the present worth will be equal to 1849.38. And when you compare this result with the previous one, you would see that the present worth is reduced. In the previous version, the present worth was $3,013, but here is 1,000. And what is the reason? The reason is actually this. In the previous version, you are increasing your payments, but in this one, you are decreasing your payments, and the starting values for both of them are the same. So in the second one, the present worth should be less than the present worth of the first one. And once you have these present worth values, you can simply calculate the annual equivalent or future equivalent values. So let's consider another example. It's said that the first payment is this much in a cash flow. Okay, so as we said, unless it is not mentioned, all the payments should start at the end of the first period. Okay, and it means that this A1 appears $54,600. And then it increases at a rate of 1.7%, which means that for the second one, I will multiply this A1 value with 1.07 to the power 1. Okay, so 7%, remember 7% is 0.07. Don't make a mistake here, it is not 0.7. So some or most of the students do a mistake here, and then all the question becomes wrong. The answer is wrong. And then it increases at the same rate until period 5 according to this. And the interest rate is 12%. So we need to find P. Again, we will use exactly the same. Again, we will use exactly the same formula. Okay, so it will be A1 times this 1 minus. Look, this time we are not using the factor, but we are using the formula itself. Okay, this is 1 plus f to the power 5, 1 plus I to the minus 5, and this is I minus f, and we find the present worth in this way. Look, it's important. In the quizzes or in the questions, if it says use factor and factor tables, you have to solve the question using factor. If instead of factor tables you use the question with a formula, in engineering economy we don't accept it. Okay, the question is to find the solution using the factor. So using these factors and factor tables is an important part of the question. You have to solve exactly as it is requested. So also sometimes we ask you to solve the question using the formula. We don't want you to use a factor table in that case. Okay, again, it's important for you to solve and obtain the result using the formula. Okay, this is a practice problem for you. Please try to solve this problem by yourself and you will understand or you will learn these geometric payment series better.